Good morning, I'm Mr. Precella, and this morning I want to discuss solving rational equations for my Math 13-14 class. I know in order for anyone to be sitting in a college algebra class right now, they have to have solved rational equations before sometime. And the method that you would have used was to eliminate any fractions by multiplying through by the least common denominator. Excuse me. But we need to remember something. When you're eliminating denominators, eliminating fractions, you get something that doesn't have fractions. You'll come up with a polynomial equation. Usually it'll be quadratic, at least for our purposes. Either way, quadratic expressions are always defined, but fractions are not. You're going to have to remember, when is a fraction undefined? That's my question. When is a fraction undefined? When is a fraction undefined? And yes, when the denominator is equal to 0. When the denominator equals 0. So here's the way to remember that, okay? When is a fraction undefined? If you have a number divided by 0, what does that say? No, you can't perform that division. That fraction, that division, is not defined. Because no matter what you take, no matter what number you put here, when you multiply it by 0, it doesn't give you back that number up there on top, because if you're multiplying by 0, you're going to get a 0. So just remember, fractions undefined when the denominator's equal to 0. So once we solve the equation, so once we think we have the solution to the equation, we're going to have to check. We will need to verify that our solutions, notice I'm putting solutions in quotation marks, we'll need to verify that our solutions, the numbers that we get that we think are solutions, I should say, do not produce a denominator of 0. And to illustrate this, I have a problem here. This is number 1. I printed out some examples that I wanted to do this morning, and without actually solving the equation, list all possible numbers that would have to be rejected if they appeared as potential solutions. So, well, we have two different fractions. Neither of those fractions can be undefined. That means x plus 1 can't equal 0. That means we can't get x as negative 1 as a solution. What's the other possibility? X minus 3. We can't let x minus 3 equal 0. That means we don't want x to be 3. So over here in our box on My Math Lab, we would type in the solutions cannot include. They can't include negative 1. They can't include positive 3. And any questions there? Okay, let's look at another one where we're just determining the numbers that we can't include in the as solutions. Look at number 2. Let me move the page up some, okay? Decide what values of the variable cannot possibly be solutions for the equation. And notice it says do not solve. We're not going to solve this equation. We just want to know which numbers cannot be solutions. So here we are at number 2. 1 over x minus 2 plus 1 over x plus 4, which equals 1 over x squared plus 2x minus 8. Well, we can't allow either of those denominators to be, either of the denominators to be 0. X minus 2 can't be 0, which means that x can't equal 2. X plus 4, it can't be 0, which means x can't be negative 4. But the third denominator, x squared plus 2x minus 8, we can't let that equal 0 either. And this is a convenient coincidence. That's quadratic, but we can factor it. How can it be factored? Yes, x plus 4 times x minus 2. It's the product of the other two denominators, which does happen from time to time. So that means we get, once again, the same numbers, negative 4. X can't be negative 4, and x can't be positive 2. So which numbers cannot be solutions? Cannot be solutions? 2 and negative 4. Any questions there? You're getting to use your solving quadratic equations technique by factoring there. So right here on number 2, which numbers can't be solutions? What goes in that box? We said 2 and negative 4. Just like negative 1 and 3 went in that box there. But it can't stay like that forever. We're going to have to start solving these things. So look at number 3. Number 3 down here. We want to solve the equation. Before we solve it, what number cannot be? There's only one number we'd have to discard. What number cannot be a possible solution? 2. Yes, I agree with 2, because we can't let this denominator never equals 0. That denominator is always 2. It's a constant 2. But this denominator, we can't let it be 0. That means we can't let x equal a positive 2. So if we solve this thing and then wind up with x equaling 2, we have to discard that as a solution. Now, number 3, I've already written it down over here. Let me make sure I didn't miscopy it. 2x plus 4 over 2 minus 3x over x minus 2 is equal to x. And we want to solve this equation. When solving an equation containing fractions, the technique that you would have seen in your, if you took the refresher course, intermediate algebra, or if you didn't take one of the refresher courses, if you took high school algebra, then the technique you would have seen would have been to multiply through by the least common denominator. When I look here, I notice neither of those denominators can be factored. So whatever we multiply by, it's going to have to cancel out this denominator. It's also going to have to cancel out that denominator. So let me recopy the problem. It's a 2x plus 4 over 2 minus a 3x over x minus 2 is equal to x. We're going to have to multiply through to cancel out both of those denominators. What can we multiply through by that will cancel out not only the denominator 2, but the denominator x minus 2? Yes. 2 times x minus 2. I agree. These students out here are whispering, so that means the microphone's not catching them, but that's fine. And realize that fraction is a single term. This fraction's a single term. Moving to the other side, we have another term, x. There are 3 different terms here. We're going to have to distribute this 2 times x minus 2 over all 3 terms. In the first product, the 2's cancel. That'll leave me the blue x minus 2 times the 2x plus 4 minus. Now the second product, the x minus 2's cancel, so all we have is a 2 times 3x equals, what's going to cancel when we multiply here? There's no denominator, so nothing's going to cancel. You'll just have the 2 times x times the x minus 2. Now we have a lot of parentheses we have to get rid of, but we know how to do that. We're just going to have to FOIL and distribute to get rid of the parentheses. So at this point, we start going through eliminating parentheses, FOILing that out. We get a 2x squared first, outer, inner, last, negative 2 times 3x, that gives us a minus 6x equals, and on the right hand side we have a 2x squared, what else? And a minus 4x. Don't forget to distribute there. Oh, this is nice. I see something very nice that's happening. If we tried to combine our x squared terms, let's move this 2x squared over to the left side. What's going to happen? 2x squared minus 2x squared. We have no x squared terms remaining. That's nice. Negative 4x minus 4x, that's a negative 8x. Minus 6x, that's a negative 14x. Plus 8 equals a negative 4x. And I'd add the 14x to both sides here. That would give me a 8 equals, what are we getting there? A 10x. And I see students are here yelling out. They're not yelling, they're trying to get my attention. They don't want to say anything. I miscopied something here, didn't I? Yeah, I think I made a mistake. What did I do? The 2x plus 4, what did it become there? That's the sort of thing you have to be careful of. That should be a plus 4. So first, outer, that's a positive 4x. Inner, there's the negative 4x. And last, oh wait a minute, instead of a plus 8, we're going to have what? Yes, we'll have a negative 8. Sorry about that, but if y'all had called it out sooner, that would have helped. So first, 2x squared plus 4x minus 8. There we have a minus 6x. All of that's okay at least. But be careful, that plus 4, I made it a minus 4 accidentally. And you know something? I'm just going to mark out all of that. Move it up. The 2x squared still subtract out. Hey, what's about to happen here to the 4x minus 4x? Those are gone too. So all we have is a negative 8 minus 6x equals a negative 4x. Add 6x to both sides to give us negative 8 is equal to negative 4x plus 6x. That's a positive 2x. Divide by 2 to give me x equals a negative 4. Now is negative 4 okay as an x value? What's the only number we couldn't have here? We said we couldn't have a 2. Where is it? Right there. We can't let that denominator be 0, so we can't have a 2 as our answer, but we didn't get a negative 2. So our final answer is negative 4. We come over here to number 3. Here we are. Well, right there in that box on my math lab, what would we type? The solution set is negative 4. Any questions there? Next time when y'all spot something, or if you just think you spot something like that, call that out. Call it out to me. Oh, and I'm telling this to the students sitting in this room. I know that if you're watching it at home, you can't call that out to me. I'm not that stupid. I know that. So I'm talking to the people out there that are sitting here in the classroom right now, being as quiet as they can, trying not to cough or say anything. Anyway, number 4, let's do another one. Let's see if I can do this one without messing up. There, solve the equation x over x minus 9 equals 9 over x plus 9 plus 10. And make sure I didn't miscopy the problem. Now you see why I always do that, because I do make little mistakes like that. But once again, we have 3 terms here. What's the only x value that would be unacceptable as a solution? Those denominators are equal to 0 when x is equal to, yes, 9. So make a note to yourself. You better not get 9. If you get x equals 9 as a solution at the end of this, you're going to have to cross it out. But what do we need to multiply through by in order to eliminate the denominators? Only denominator up here in x minus 9. I agree. So we're going to multiply through 1, 2, 3. In the first product, the x minus 9's cancel. What are we left with? Just x, okay, equals second product. The x minus 9's cancel, leaving me with just a 9 plus the third product. What's going to cancel? Nothing's going to cancel. You'll just have a 10 times an x minus 9. I'm going to write that as a 10x minus 90. This isn't quadratic, at least. No x squares. You don't have to worry about factoring or the quadratic formula. I'd move the 10x over to the left-hand side. Moving the 10x over to the left-hand side, 1x minus 10x, that's a negative 9x. And 9 minus 90, 9 minus 90 gives me a negative 81. Divide both sides by negative 9 to give us x equals a positive 9. But remember, what number did we say would be unacceptable for x? What number makes these denominators 0? If you plugged in a 9 here and here, you'd get 9 divided by 0. That is unacceptable. This gives a denominator of 0, so we say 9 is an extraneous solution. 9 is an extraneous solution. That's what you call that. So, if 9 doesn't check, we didn't get any other possible solutions, in that event there is no solution to this equation. So number 4 here, we would choose the solution set is empty. There are no numbers that'll make the left side equal the right side. Any questions there? Okay. Now, number 5. I wonder if we're going to have an extraneous solution here. Instructions just say solve the equation 4 over x squared minus 55 over x equals 14. Okay, well, what can we multiply through by to cancel out those denominators? A common mistake is for people to say x, multiply through by x. If you just use a single factor of x, if you multiply through by x, would you cancel out that entire denominator? No, you wouldn't. If you have repeated factors serving as denominators, then and you had multiple exponents. This is an x to the first, that's an x squared. For the least common denominator, you use the largest exponent, x squared. Now multiplying through by x squared on both sides, seems like all these problems have 3 terms in them, 2 on one side and 1 on the other. When you perform the multiplication, the x squares cancel. That gives us a positive 4 minus, multiply by x squared. One of the x's cancels. What do we have left then? We have that 55. What else? We have one of those red x's left. Equals, what's going to cancel in the third product? There's no fraction, so nothing's going to cancel. It's just going to be a 14 times x squared. And this is quadratic, so I'm going to try to solve this by factoring. Now, if I'm going to solve this by factoring, I need to get one side equal to 0. I like that leading coefficient to be positive, so what I'm going to do, I'm going to leave the 14x squared on the right-hand side. I'm going to say that I'll have a 0 on the left side. I have a 14x squared. Move all those terms over. That'll become a plus 55x. And what else? A minus 4. I agree. And let's see. We'll try to solve this by factoring. I'm going to write my two sets of parentheses. And 14x squared, well, let's see. That could be a 2x times a 7x or 1x times a 4x. 2x squared, that's a 1x times a 14x or 2x times a 7x. As I'm going through this in my head, I'm playing out the factorizations in my head, and I can't seem to get 2x and 7x to do what we want it to do. But I'm going to try the 1x and the 14x. And why am I making that decision? Just because I was playing around with the possibilities in my head, and I don't seem to give me, I can't seem to get that plus 55x that I need. Now for 4, we could use a 1 times 4 or 2 times 2. Well, it can't be 2 and 2, because if you put a 2 here, you'll have a common factor of 2, and you can't have a common factor inside a set of parentheses if the expression is factored completely. So I'm going to try the 1 and the 4. There it is. I see it. Oh, and by the way, I forgot to ask you, what do we know about the signs? That last sign's a negative. So what do we know? How do we get a negative product? 1 positive and 1 negative. I agree. Put the plus there and the minus there. Does that give us back? When you FOIL that out in your head, do you get back 14x squared plus 55x minus 4? All you have to really check is the outer and the inner. The outer product, x times negative 1. Here's my mental checking. That's a negative 1x. That's the outer product. The inner product, positive 4 times 14. That's a positive 56x. Does that give me a positive 55x? Yes, it does. So that's the correct factorization. Set each factor equal to 0. To give us x is negative 4, or x equals a positive 1/4. 1 over 14. Thank you. This time, I guess the students have learned to call out the mistakes when they spot them. 1 over 14. And I didn't ask all this at the beginning of this problem, but what's the only number that would be unacceptable for x? What number would make those denominators equal 0? It's the same number in both cases. Okay, when x is 0. If x is 0, you'd have a 55 over 0 or a 4 over 0. Did we get 0 as our final answer? No. So both of these answers are acceptable. We're at number 5. Where's number 5? Right here, number 5. And so our two numbers, our two solutions were, what are they? Negative 4. Let me fold this there. Our two solutions, there's my little arrowhead, are -4 and +1/14. And when you're typing that into my math lab, do not put spaces. Use a comma to separate your answers. Do not put spaces. It looks like I'm putting spaces there, but I'm not typing. I'm writing it in, okay? So, but there are no spaces.
It's spaces that correct.
It does. So, anyway, I think I'll take a break right now, and maybe we'll do some more of these in a little bit. Bye-bye.